Hi guys, welcome back to our mathematics tutorial, and my name is Peter C. Dogba Jr., math instructor at the University of Liberia and your math tutor. In this lesson, I will be discussing how do we go about deriving the Pythagorean trigonometric identities. So let's get started. Now the Pythagorean trigonometric identity is a fundamental identity that can be used to derive the half angle identity, the double angle identity, and several other identities. So it's very, very important. So let's learn how we can derive it. Now, consider a cycle. Let's consider this cycle, for example, and draw a coordinate system that runs through the center of the cycle. So this is our X, and this is our Y. Now, we can also draw a triangle. Leads from here, connect this circumference, and we'll drop this. So we can call this angle right here angle theta. Now, this side from this origin to this point right here, we can call it some x. From this point to this circumference, we can call it some y, because this is on the y-axis, this is the x-axis. And from this circumference to the center, we can call it some r, because it's the radius of the cycle. So since we are dealing with a cycle with the center at its origin, we can use the equation of a cycle with center at its origin. So if we do that, we will see that the equation is x squared plus y squared equals r squared. So now, we know that from our previous lesson that the trigonometric function sine and cosine, we know that sine is defined as opposite side or over hypotenuse, and cosine is defined as adjacent side or over hypotenuse. Now, the reason why we are bringing it in, because we need to solve for x and y within this equation, thereby replacing them with trigonometric functions. So sine of, now if we want to relate it with this angle, thereby saying that this angle is our reference angle, sine of theta is equal to opposite side. So which side is the opposite side to this angle? So if we look here, y is the opposite side and the hypotenuse is r. So if we just solve for, because we need to find r, and we need to find y and x. So if we solve for y right here, we have y to be equals, we just cross multiply, r sine of theta. Then we move to cosine. So we know that cosine is equal to the adjacent side over hypotenuse. So we can define cosine on this triangle. So we say cosine of, or cos of theta now equals, adjacent side now is x, and the hypotenuse is r. So we cross multiply, x times 1 is x, r times cos of theta is r cos of theta. So what we need to do is to replace x and y within the equation of a cycle with the center at its origin. So x squared plus y squared equals to r squared. X is r cos of theta, but raised to the second power, plus y now is r sine of theta, what we got from your right here, raised to the second power equals r squared. So this means that we must multiply this entire expression twice. So we can say r cos of theta times r cos of theta plus r sine of theta times r sine of theta, all equals to r squared. So now we have r times r to be r squared. Cos of theta times cos of theta is cos square theta. So we don't square the angle of a trigonometric function. We square the trigonometric function by saying cos square theta or cos of theta all square. So those are out of the ways we can square this trig function. So we have plus r times r again is r square, and then sine of theta times sine of theta is sine square theta, all equals to r square. So what do we know? We know that r square is in every term. So therefore we can divide this by r square, and by r square. So each of them going to itself one time. So we will have cos square theta plus sine square theta is now equals to 1. So this is how we derive the fundamental Pythagorean identity for the trigonometric function. So this is cos square theta plus sine square theta equals to 1. So from this identity now, we can be able to derive several other similar trigonometric identities, that we refer to as the Pythagorean identity. So we will do that in next video, wherein we will derive several other identities using this fundamental Pythagorean identity. So thanks ever so much for watching. See you in our next lesson.